Hey everybody, Dr. A here, and in this video we're going to be exploring another example dealing with three-dimensional Cartesian vectors. So let's go ahead and get started. In the given information, we're being asked to compute the magnitude and coordinate direction angles for the force F1. So let's take a look at the given figure. Here we have this three-dimensional figure. We've got our positive x-axis here. We also have a negative x-axis coming back here. We have a positive y-axis pointing off to the right. We have a negative y-axis pointing to the left. We have our positive z-axis pointing up and our negative z-axis pointing down. Now, coming out of the origin, we have 4 vectors in total. We have 3 force vectors, and then we have their resultant force. So let's take a look at what we're given to us. The first force vector, which is the one we're trying to find, is F1. That's coming off right here, okay? So we have the tail at the origin and the head somewhere down here. And we see we also don't have its magnitude, right? When in fact, we're being asked to find its magnitude. So if you look here, that's unknown. Now, its coordinate direction angles are also unknown. You have alpha 1, which is a coordinate direction angle measured from the positive x-axis to the vector itself. You have beta 1, which is the coordinate direction angle measured from the positive y-axis to the vector. And then you have gamma 1, which is the coordinate direction angle measured from the positive z-axis to the vector itself. So everything about F1 is unknown at this point. But what we do know is some information about F2, F3, and the resultant force. So F2 has a magnitude of 200 pounds, and it's completely lying along the negative y-axis, okay? Now, what about F3? F3 is coming off in the xy plane. Notice that it does not have a z component. F3's magnitude is 300 pounds, and it has a 30-degree reference angle from the positive y-axis, but it completely lies in the xy plane. So it's going to have an x component, which in fact is going to be negative because you see it's angled in quadrant 2. It's going to have a y component, and it's going to have no z component, so a 0 z component, okay? So that's what we're looking at here for the 3 vectors. Now, they all combine together to come together to form this resultant force here, which has a magnitude of 300 pounds, and it's given by this blue vector, which is pointing along the negative z-axis. So what does that tell us about the resultant force? Well, it says that this resultant force, really its direction, since it's purely in the z direction, is going to be negative 300 k whenever we write the resultant force as a Cartesian vector, okay? So we pretty much know everything we need to know about F2, F3, and the resultant force, and we're trying to find all the information out about F1. So how do we piece this together? Well, we're going to start by saying solution, okay? So let's write the solution, and then we're going to say that the resultant Cartesian force vector is going to be equal to what? Well, we're going to say sum of the forces in the x direction times I plus the sum of the forces in the y direction times j plus the sum of the forces in the z direction times k, okay? And so all of that combined together is going to be equal to what? Well, it's going to be equal to that negative 300 k, and it's collectively going to have units of pounds. How do I know that? Where am I getting this negative 300 k from? Well, again, from our given figure, the resultant force here in blue is pointing in the negative z direction, and it has a magnitude of 300 pounds. That's where the negative 300 is coming from. So what I have to do now is determine each of these sums, right? And so we're going to do that one at a time. Let's start with sum of the forces in the x direction. So what I'm going to do is I'm going to find the x component of all 3 of these red force vectors, F1, F2, F3, okay? Now, the first one, F1x, I don't know, so I'm just going to leave that as F1x here. And then I'm going to say plus F2x, which I'm going to be able to get that here in a second. And then I'm going to say plus f3x, which again, I'm going to be able to get that in a second. So again, we're going to say equals f1x. We don't know that one. What is f2x? So what is the x component of force 2? Well, if you said 0, you'd be correct. If you look here, F2 is pointing completely in the y direction, specifically in the negative y direction, but it has a 0x component, so that's gone. F2x is gone. What about F3x? I'm looking for the x component of this F3, okay? So what do I do to get that x component? Well, I can look at this right triangle right here. So if I wanted to extract that right triangle and do a little bit of work off to the side, here's what I can do. I can draw this magnitude here as F3 is 300 pounds. And I've got my help lines here. There's that right angle. And so this component is my F1, I'm sorry, not F1, F3y, and this component is my F3x, okay? How do I know that? Well, again, I'm looking at this right triangle right here, okay? Looking at this right triangle. So this is the x component because it's parallel to the x-axis, and this is the y component along the y-axis. And of course, I have this 30-degree angle inside of it. So I can say F3x is equal to negative 300 pounds times the sine of 30 degrees, which of course is just going to be negative 150 pounds. And then I can get F3y is 300 pounds times cosine of 30 degrees. And let's punch that in our calculator. 300 times cosine 30, I get basically 260 pounds, okay? So what am I interested in at this step? Well, I need F3x, so I'm gonna go ahead and write that here as negative 150 pounds, okay? And guess what? I'm gonna say that equals 0. Where am I getting this equals 0 from? Well, remember, all of this equals the resultant x component. What is the x component of this resultant force? Of course it's 0, right? All you have is it pointing in the negative z direction. It's equal to negative 300k. So the I component or the x component of the resultant force is 0, and that's what this means right here, equaling 0, okay? So with that said, I can immediately rearrange this, and I could say, hey, F1x is equal to what? Well, it's just equal to 150 pounds, okay? So now, guess what I just figured out? I figured out the x component of F1, which is part of what I need to do to solve the problem, okay? So what do we do next? Well, we're going to move on to some of the forces in the y direction, and of course, that's going to give us the resultant y component, all right? So let's write that out. Some of the forces in the y direction equals, of course, that's going to give us F1y, which we're trying to find, plus F2y plus F3y, okay? So we're going to say equals, again, we're looking for F1y. We don't know that yet. What about F2y? Well, we go back to the original figure, and we see that F2 is pointing in the negative y direction purely, right? So it's only got a y component, and it's pointing in the negative y direction. So I'm going to be able to say minus 200 pounds, okay? What about F3y? Well, we just figured that out when we were analyzing F3 by itself over here. We got that F3y is a positive 260 pounds. So I'm going to add that there, plus 260 pounds, and that's all going to equal 0 again. And remind me again, where does this equal 0 come from? Well, remember, the resultant force only has this negative z component. Its x and y components are both 0. So this equals 0 term refers to the fact that it has a 0 y component. all right? And I can do something similar here. I can do some rearranging, and I can get the y component of 1, so that's going to be f1y, and sure enough, that comes out to be negative 60 pounds, all right? So that's another part of our answer. Now, what about the last component? What about the z component of force 1? Well, we'll follow the same pattern here. We're going to say sum of the forces in the z direction equals f1z that we're looking for plus f2z plus f3z, okay? And so again, we're looking for f1z, so I'll rewrite that equals f1z. What are f2z and f3z? Well, look at this. f2 purely along the y-axis, and f3 is only in the xy plane. Neither f2 nor f3 have a z component. So what does that mean for this little relationship here that we're building out? Well, that means that f1z must just be equal to negative 300 pounds. And that negative 300 pounds, where's that? Well, that's the z component, or you could say it, think of it as the k component of the resultant force, okay? And so what do I finally have here? Well, my Cartesian force vector 1 is just going to be 150I minus 60J minus 300K. And again, this is collectively carrying units of pounds, all right? So that's part of my answer, or what I need to get to my final answer. The problem asks for the magnitude of F1. So I'm going to use the Pythagorean theorem to calculate the magnitude of F1. And so I'm just going to say that's going to be the square root of 150 pounds squared plus negative 60 pounds squared plus negative 300 pounds squared. And then I'm going to square root all of that together. Be careful with your calculator punching. And remember, you're squaring these negatives as well. So really, you know, it doesn't, honestly, for the calculator purposes, it doesn't really matter if you put the negatives inside here because you're squaring them and it's going to become positive anyway. But I write the negatives on my handwritten work to show complete correctness, okay? So I calculate this magnitude and I get about 340.7 pounds as my magnitude. And that's part of my answer. It asks for the magnitude of F1, and then it also asks for the coordinate direction angles for the force F1. So how do we get those? Well, we'll get alpha 1 is the arc cosine of F1x over the magnitude of F1, all right? And so that's just going to be the arc cosine of 150 pounds over 340.7 pounds. And when we punch that through, we should get about 64 degrees, okay, or maybe 63.9 degrees. But that's one of our answers. What about beta 1, the coordinate direction angle beta 1? We're going to say that's the arc cosine of F1y over the magnitude of F1. And so I punch that through, and that'll give me arc cosine of negative 60 pounds over 340.7 pounds. Now remind me, does this negative matter? Do I need to include this negative in my arc cosine operation? Yes, absolutely, absolutely. So you punch that through, and you get about 100 degrees. And then finally, I'm going to get gamma for F1 is going to be the arc cosine of F1z over the magnitude of F1. So we'll write that as arc cosine of negative 300 pounds over 340.7 pounds. and we should get 151.7 degrees. And those are my coordinate direction angles. You might could write this as 152 degrees if you want to go to 3 sig figs. Okay, so that concludes this example. Again, we got our answers, the magnitude of F1 and the 3 coordinate direction angles. So thanks for watching. If you found this helpful, please hit like and subscribe and be on the lookout for other content like this.